Hi there everyone, and welcome to week 10 of our exam countdown on the TheMathsTutor.ie. So as you can see, this week we're going to be concentrating on a huge part of paper 1 normally, applications of differentiation. So full members, you will have access to loads of resources on TheMathsTutor.ie exam countdown page. And don't worry if you're not a full member, I've linked 2 videos in the chat, 2 very useful videos. Rates of change using a distance, speed and acceleration example, and the second one there, again rates of change but using more complicated functions that require the use of the chain rule. Okay, so let's get straight in for this week. You'll see here on your screen, I have just made note of the 4 different ways that we mentioned the last time that you can be asked to differentiate. So dy dx, f dash x, slope of a tangent to a curve, and the rate of change of y with respect to x. And those are just all different ways of asking us to differentiate or to find what we call the derivative. Okay, and we're going to just focus in today on this one specifically, slope of a tangent to the curve. So just to start us off, I'm going to just draw a rough sketch of a cubic function here. And as we said last week, if you pick different points on that curve, so for example, a point there, the slope of that tangent would be positive. And if you picked a point over here, the slope of the tangent at that point would be negative. And today, we're just going to zone in specifically on this point up here, the max, and this point down here, the minimum point. So if I was to draw a tangent at that point, at the max or at the min, just like that, you can see that it's a flat line. So this is my maximum and this is my minimum. And you can see that the slope of the tangent is clearly 0 because it's just a horizontal, it's a flat horizontal line which doesn't have a slope. So in short, what we've just said is at the max or min of any function, then dy dx or f dash x or the slope of the tangent to the curve is 0. And that's probably the most important thing that we're going to look at and use today. Also, you might also notice that as you're coming up to the maximum point, the slope all along here will be positive. It goes to 0 at the maximum and then it changes to negative. It goes to 0 at the minimum and then again it's increasing. It's positive after the minimum point. So that also tells us something else, and it tells us something about f dash x. Your second derivative is always going to be negative at a maximum point. Why? Well, because it changes, as you can see here, it changes from positive into negative, and it's always going to be, your second derivative is always going to be positive at a minimum point. Again, why? Well, because it's changing from a negative to a positive over here. Okay, so that's probably the easiest way of remembering that. So those 2 things. At the max and the min, the first derivative is 0. And at a max, your second derivative is negative. At a min, your second derivative is positive. So these over here that we've just written, that's like our test or our check to check whether it's a max or a minimum point we're talking about. Now, obviously, if you have a quadratic function, if it's U-shaped, it only has a minimum point. And if it's N-shaped, it only obviously has your maximum point there. Okay, but if it's a cubic, like this one that we had up here, it's going to have a max and a min. So it's important that we're able to test or check which one is the max and which one is the min. Okay, so we're going to have a look at a couple of exam questions today, and we're going to start with 2014 paper 1. You're going to notice as we go through the exam questions, functions comes up quite a lot in calculus. They kind of come hand in hand in paper 1. Okay, so 2014 paper 1 question 5, and we'll jump straight into it. The function f is defined as this one. So as you can see, it's a cubic function, just like I've drawn above, and it's telling us that x is a real number. So part 1 asks us to find the coordinates, so it's looking for x and y, of the point where the graph cuts the y-axis. Okay, so let's just have a think about that for a second. If we have a y-axis and we have an x-axis and we have a cubic function, so we're looking at something like this. Again, this is not drawn to scale. It's just, we know it's going to be an S on its side. And what we're looking for in this case is we're looking for that point there, the coordinates of that point where the graph cuts the y-axis. But if you just imagine for a second, any of those points along the y-axis, they all have one thing in common. They all have x equals 0. So at every single point along that y-axis, x is going to be equal to 0. And that's what we're going to do in part 1 to find where the graph cuts the y-axis. We're going to let x equal 0. So we're going to take our function and we're going to replace x with 0. So everywhere we see an x, we're subbing in a 0 in brackets instead. And you'll see then what happens is that term, and that term, they all end up cancelling out and we end up getting f of 0 is equal to 5. So that tells me that my coordinates are, well, when x is 0, because that's what we subbed in, our y, or our f of x, because they mean the same thing, is 5. So the coordinates of the point where the graph cuts the y-axis, as asked for in the question, are 0 and 5. Okay? So part 2 asks us then to verify, so we're checking that the answer is correct, that the graph cuts the x-axis this time when x is minus 5. So if I just go back to my previous diagram up here, now I'm looking for where the graph cuts the x-axis and we're hoping that one of those points is equal to minus 5. So you can see from my diagram, again, we're not completely sure if it's accurate, it cuts the x-axis at 3 points. But we're just checking that one of those points is going to be x is equal to minus 5. So again, if you look at your x-axis up here, all those points along the x-axis, they all have one thing in common. They are all where y is equal to 0. So every single one of those points along the x-axis, y is 0 because you don't go up or down the y-axis at all. So this time, we're taking our function, f of x again, and this time, we're letting y equal 0, and y and f of x are the same thing, so we're letting our function equals to 0. Now we're verifying that that happens when x is minus 5, so we're going to sub in minus 5 for x and see what happens. So minus 5, we make sure that we put it in brackets into every single term, and we're hoping that it does equal to 0. So what we're getting is minus 125 plus 75 plus 45 plus 5. And when you work the left-hand side out there, you're getting 0. So that verifies our answer. And we can say, therefore, it cuts the x-axis at x equals minus 5. So make sure that you're answering your question. Okay, so part B then is where the calculus comes into play. We're looking for the coordinates. Again, that's going to be important. We're looking for not just x, but x and y of the local maximum and the local minimum turning point. Okay, so as we said, when we see max or min in a question, the first thing we write down is at the max or the min, our derivative is equal to 0, because remember the slope of the tangent at the max and the min, the tangent is horizontal, so it has a slope of 0. And just for writing this down, in most marking schemes, you will get marks, okay? Just one thing to add there, sometimes instead of using local max or local min, they might mention stationary points. And those are exactly the same things. So stationary points or local max or min or turning points, they all mean exactly the same thing. So we're just going to remind ourselves of what our function was. It was x cubed plus 3x squared minus 9x plus 5. And what we're going to do, we're going to differentiate and we're going to let our derivative equal to 0. So f dash x, remember we multiply down by the power, so the 3 comes down in front and we reduce the power by 1. The 2 comes down, multiplies the 3, we get 6x to the power of 1. If it's a number in front of the x, which we have here, you just drop the x, and if it's a constant on its own, it goes to 0 when you differentiate. So we're letting our first derivative equal to 0, and you'll see right there you have a quadratic. So we can solve it using guide number or minus b. I'm going to go with minus b, so I'm just writing out my formula. And that's coming from your log tables on page 20. So my a, in this case, is going to be 3. My b is going to be 6, and my c is going to be minus 9. So that's x equals minus 6. I'm just subbing in brackets all the time, just to make sure. Remember, it's a minus 9 for c, and it's all over 2 times a, which in this case is 2 times 3. So you should be getting 2 answers for yourself. One answer is x equals 1. The second answer is x equals minus 3. But remember, it asked us up here for the coordinates of the max and the min. So before we figure out which is a max and which is a min, using our second derivative, we're going to work out what the y coordinate for each of those x's is. So we're always subbing back into the original, because remember, f of x and y are exactly the same thing. So f of 1, you're subbing 1 in everywhere you see an x, and that should give you 0. And f of minus 3, you're going back to the original, remember, back here, and you're subbing minus 3 in everywhere you see an x. You should be getting 32 for your y coordinate. So those are my 2 points. 1, 0 is one of them, and minus 3 and 32 is my second point. One will be a max, one will be a min, and we're going to use our second derivative test just to check which is which. But before we do, just going to let you in on a nice little hint here. A quick way of figuring out which is the max or which is the min for cubic functions is have a look at your y coordinate, and whichever is the higher one, so the one further up the y-axis, that's going to be your max. So in this case, we're assuming this is our max, and the 0 is below 32 on the y-axis, so we're going to assume that that's our min. But we're going to just double check just to ensure that we have achieved all of our marks that we can. So remember what we said back up here. We said we use this test or this check, just back up here. Yeah, we use this test or we use this check to see which is the max and which is the min. So we're going to work out the second derivative, and we're expecting when we sub in the value of x, that it's going to be negative at the max and it's going to be positive at the minimum point. So our first job is to find our second derivative, our f double dash x. So we're going to go back to our first derivative, which was here, and we're differentiating. So we're getting 6x plus 6. So we're going to sub in 1, see what that gives us, and we're also going to sub in minus 3 and see what that gives us. So it becomes 6 times 1 plus 6. That gives us 12, and we know that 12 is positive. We're not too interested in what the number is, we're just interested in whether it's positive or negative. So in this case, it's greater than 0, so therefore that point 1, 0, we know that the second derivative is positive at a minimum point, so that is just confirmed for us that that's our minimum point. We're going to do the very same over here. 6 times minus 3 plus 6 this time. That's going to give you minus 12. Again, I'm not too interested in what the number is. I'm just really interested in whether it's positive or negative. So in this case, it's negative. So that tells me that the point that has minus 3 as its x coordinate, that's going to be your maximum point. Why? Well, because the second derivative is always negative at a maximum point. Okay, so really, it's vital that these two pieces of information up here, so this one and this one, that those are memorized, okay? Because they're really going to come up every single year. Max or min questions come up in some shape or form, okay? So we're going to have a look at another one, and this brings the question into some sort of a context. So it's not just a cubic function as such, it puts a bit of context in the question. So this is 2014, again, paper 1, question 8. This is one of the longer questions. You can see there it's worth 40 marks. So part A, the length of the side of a square sheet of cardboard is 12 centimeters, and we're looking for the area of the sheet. So just to draw a quick diagram, we have a square sheet of cardboard of length 12, so its width is also 12 because it's a square, and we're looking for the area. So we know our area is just going to be length by width, which in this case is 12 by 12. So that's 144, and it's centimetres squared because our units are centimetres. So nice and easy to start off with. Part B then. The diagram below shows a square sheet of cardboard. So again, it's a square of length, side length 12, from which 4 small squares, each of side length h, have been removed. The sheet is then folded up to form an open rectangular box of height h. Okay, so you're shown in the diagram, and you can see here that there's a little square cut out of each of those corners. There's a little square cut out of length h centimetres. So we're looking for the length of the box in terms of h. So you can see here the length is 12, but we're cutting out a little part h here and another little part h, a little length h from the right hand side. So that leaves me with 12, but we're taking 2h away. So my length is 12 minus 2h, and exactly the same thing is going to happen here with the width, because that width is going to be 12, but we're taking away h and we're taking away another h. So my width is also going to be 12 minus 2h in this case. And they've told us that the box obviously is of height h when you fold up those 4 sides. So show that the volume of the box in terms of h is given by that function. So we're looking for the volume in terms of h. So my function is v and my variable is going to be h. We know the volume of any rectangular box is just length by width by height. So let's remind ourselves our length was 12 minus 2h times our width was also 12 minus 2h, and our height, we were told in the question, was h. So our job is to multiply all 3 brackets together, and I'm just going to take 2 at a time. Sorry, you can put that in brackets also if you want. I'm going to take those first 2 and I'm going to multiply them by back-to-back brackets. So I'm going to split that first bracket in half, and I'm multiplying 12. Sorry, that should be obviously a minus 2h there as well. So 12 by 12 minus 2h minus 2h by 12 minus 2h. So that's giving me 144 minus 24h minus 24h, and it's a plus 4h squared. And don't forget that we also have to multiply in by the h at the end. So simplifying what's in the first bracket, it's 144. These two can go together as minus 48h plus 4h squared, and we need to multiply in the height. So that will give me 4h cubed minus 48h squared. So I'm just going to write them in order of degree, plus 144h. And that, we'll remind ourselves, that was my volume in terms of h, length by width by height, and that's exactly what we expected it to be from the question. So part D then asks us, find the value of h. So h is what we're looking for, which gives the maximum, there's that word again, and this time it's maximum volume. So straight away we see maximum, and we write down that at the max, in this case v dash h, is equal to 0, and we're getting marks. We should be picking up marks just for writing that. The minute I see max or min in a question, that's what I'm writing. Okay, so we're going to take our volume function and we're going to differentiate it. So v dash h is what we're looking for. Here's our volume function. When we differentiate, we're getting 3 by 4 is 12h squared minus 48 by 2 is 96h. And 144h becomes plus 144. We drop the h, just like we would drop an x if the x was the variable. And we want to know when is v dash h equal to 0. So we're going to let that equal to 0. And as you can see, again, you've ended up with a quadratic. So every time you differentiate a cubic function, you will end up with a quadratic function. So again, if you wanted, you could divide across by 12 here. You can use guide number or minus b. I'm just going to go straight to the answers. Obviously, you're showing your work. You're showing your minus b formula work here. And you should be getting 2 values of h. h is 6 and h is 2. Okay, so clearly one of these will give a max and one will give a min. So if we go back to our diagram, so h is 6 and h is 2. We'll just write this here just to remind ourselves. Now, if you think about it, when h is 6, if we take this one, for example, first. If h is 6, then the length is going to be 12 minus 2 times 6. That gives me 12 minus 12. So that gives me a length of 0. And it also gives me a width of 0 as well. So that means I don't have a box as such. So therefore, that clearly is going to be your min. And this clearly is going to be your max. Now, if you wanted, you could again do your second derivative test there just to reassure yourself. But because when h is 6, the length goes to 0, that's clearly going to be your minimum. So your answer, because it was the value of h that we were looking for, is h is equal to 2. And again, our units are centimeters in this case. Okay, so again, you're seeing that maximum volume, that word maximum coming up quite a bit. So part D, find the maximum volume of the box. So in other words, we're taking our answer from part D, h is 2, because we know that the volume is a max when h is 2. So the volume is a max when h is equal to 2. So we're taking our volume formula, which is the original formula that we started with, and we're replacing every h with a 2. So it becomes 4 times 2 cubed minus 48 times 2 squared plus 144 times 2. And you're going to sub that straight into your calculator. You should end up getting 128. And because it's volume, your units are centimeters cubed in this case. Okay, and finally, we're going to have a look at 2014 sample paper 1 and question 9. Okay, and finally, we're going to have a look at 2014 sample paper 1 and it's question 9. So part A farmer is growing winter wheat. The amount of wheat he will get per hectare depends on, among other things, the amount of nitrogen fertilizer that he uses. For his particular farm, the amount of wheat depends on the nitrogen in the following way. So there's our formula. And this is important, where Y is the amount of wheat produced and N is the amount of nitrogen added in kilograms per hectare. So how much wheat will he get? So Y is what we're looking for. Y is our question mark, if you like. If he uses 100 kg of nitrogen, so it's basically telling me that our N is 100 kg. So as we did in the previous question, we're just going to take our formula, Y, and we're going to replace every N with 100. So we're going to replace both of those with 100. So it becomes 7,000 plus 32 times 100 minus 0.1 times 100 squared. And you're subbing that straight into your calculator. You should be getting 9,200, and our units are kgs per hectare. So that's kilograms per hectare. So that's the amount of wheat that he will yield if he uses 100 kgs of nitrogen fertilizer. So nice and easy, just a subbing in question. Part 2, find the amount of nitrogen. So again, N is what we're looking for. That's our question mark in this case. He must use in order to maximize. So there's that word again, the amount of wheat produced. So in this case, we're going to say at the max. This time it's dy dn, because y is my function and n is my variable. And at the max, dy dn is going to be equal to 0. So we're going to take our function y and we're going to find dy dn. In other words, we're going to differentiate it. So when we differentiate 7,000, that goes to 0. When we differentiate 32n, that goes to 32. And when we differentiate minus, minus 0.1 n squared, we're getting minus 0.2 n. And we're letting that derivative equal to 0. We're going to solve for n. So I'm going to add 0.2n to both sides. So I'm getting 0.2n on the right-hand side. And then I'm dividing by 0.2. So you're getting n is equal to 32 divided by 0.2. So that should give you 160. and we're talking about, so remind ourselves of N, our units are kg per hectare. Now, we are pretty sure that this is a maximum amount because we're only getting one answer. A couple of ways that we can double check our answer. If you go back up here, look at your quadratic function. It's a negative n squared, okay? So we know it's going to be an n shape. So if we look at an n shaped, well, it only has a maximum. So there's the max up there. And just to double check, what we'll do is we find our second derivative. So that's going to be d squared y dn squared. And that means that I'm taking my function here and I'm differentiating it. So 32 goes to 0 and minus 0.2n goes to minus 0.2. So your second derivative is always going to be negative. So that means that this is definitely our maximum because your second derivative is negative at your maximum point. Okay? And finally, part 3, what's the maximum possible amount of wheat? So this time we are looking for y as our question mark, and we know that the maximum amount of wheat occurs when we use 160 kgs per hectare of our fertilizer. That was our answer from part 2 there. Okay, so all we do is we take our y function and we're subbing in 160 everywhere we see an n. So it's going to be 7,000 plus 32 times n, that's 32 times 160, minus 0.1 times n squared. So that's 0.1 times 160 squared. And that should be giving you 9,200 kilograms per hectare. Okay, let's just check that we have our units right. Yeah, kilograms per hectare. So we're all good at that stage. So look, that's just a sample of a couple of questions from the papers. And you'll see calculus mostly comes up, differentiation mostly comes up in paper 1. And that maximum or minimum, that comes up almost every year at some stage in either a short or a long question or both. Okay, I should have mentioned also that very first question that we did, if I can go back up here to it. So that very first question we did from 2014 paper 1, that was from an ordinary level exam paper, just to get you in the swing of things with the max and the min problems. So hopefully that was of some use to you, and I will look forward to the next time. Thank you.